Yeah, thank you. So that was fun with the quiz. So really cool. We should do that every PromCon, I think. This one is not so much about fun and entertainment, but hopefully about cool features and cool things happening in the Prometheus ecosystem. The day before yesterday, the Prometheus Java client library 1.0 came out. And yeah, I'm going to walk you through it, present you the latest features and what happened and so forth. Few words about me. So I'm Fabian. I work at Grafana. I'm a member of the Prometheus team. And as you heard in the introduction, so I'm maintainer or one of the maintainers of the Prometheus Java client. So if you have anything in the release that you like or don't like or any wishes for the future, so talk to me. I'm always happy for feedback. So the 1.0 release is not a regular release where you just update the dependency and then you're done. It's basically a complete rewrite of the underlying data model and the way that the library works and so forth. And for that reason, a lot of things changed, and there are a lot of improvements and things that are slightly different and so forth. So it's hard to come up with a complete feature list or a complete list of things that are new. But if I had to pick two highlights or two important things that come with the 1.0 release now, I would say it's native histograms and its support for OpenTelemetry. And I'm going to show you that. And as it is more or less a complete rewrite, it's also not backwards compatible. But if you are a user of the previous version, 0.16 or older, you don't need to refactor all your code now because we provide a migration module. So you can use that and bridge your previous metrics from the collector registry with the new Prometheus registry, and then you can kind of keep using your old metrics. So no need to adopt all of your code at once, right? Cool, so let's get started talking about these features. Let's start with the histogram. So this is how Java looks like, in case you are coming from a different programming language. So this creates a histogram, pretty straightforward, with a name, help message, unit, a couple of labels. And it's an example of how you would use the histogram to observe a duration. Of course, there's more API. You have different ways to observe durations and so forth, but this would be the most simple case. And as I said in the introduction, that native histograms are kind of one of the new features here. I think the first question is, if you look at this code, it doesn't specify anything, right? It just says, I want a histogram. And so the question is, if you do that, what type of histogram do you get, right? And the answer to that is, by default, this one will maintain both representations under the hood. So under the hood, it will maintain a classic histogram and at the same time a native histogram. And which one you actually see depends on how you configure your Prometheus server. So if you have a standard Prometheus server today, then the Prometheus server would scrape in OpenMetrics format and see the classic histogram. And if you start your Prometheus server with the native histogram feature flag enabled, then it would scrape the new protobuf format and receive the native histogram. And there's also a configuration option in the Prometheus server to scrape both, which is intended for migrating from the classic histograms to the new histograms. Okay? If you want to try this out, there's something it's more like a tiny thing, but I think it's pretty helpful. So what we did is we added an examples directory here in our GitHub repository. And the examples directory contains end-to-end examples of all the new features and a couple of older features. And the intention is to extend this over time. And what these have is basically example Java code so that you can set things up, but also a Docker compose that sets up a whole pipeline, with the Prometheus server, Grafana, dashboards, and so forth. So for example, if you go to the example native histogram here, you have a tiny Java program that produces histograms, but also a Prometheus server that's configured to scrape both representations and then dashboards that show you how the different representations look like and so forth. And so basically the idea is to keep maintaining these things so that for each feature, you have some working example to try out and learn about it and explore things, and then you can go from there. So back to this code. There's one thing I want to mention. So this one doesn't configure anything, like really it's just the defaults, but of course you have API here to really fine-tune what type of histogram you want. You can say, I want a classic histogram only, and with these custom histogram buckets and so forth. However, there is an issue with that, or there was an issue with that with the previous releases of the Java client, which is that typically at the time when you write that code, you don't really know what's the best configuration for your histogram. Like especially with classic histograms, when you specify your buckets, it often happens that you kind of don't really know what buckets to use. Maybe you guess something or just go with the defaults. And then when you deploy your application in production, you kind of see that the actual latency numbers that you observe are not a great fit for your histogram buckets or whatever, and then you would need to get back and reconfigure. And with previous versions of the library, the only way to do that was, get back to coding, put a different configuration there and create a new release of your application, which is obviously annoying. And so with the 1.0 release, we made almost everything that you can configure in code also configurable at runtime. So we have here's documentation for that. So there are different ways how to do that. You can specify a properties file, or you can specify, like if you just want to set one or two properties, you can also do that via a command line, via system properties, and so forth. And like these are the examples for metrics. Like if you, for example, you can say, I want the classic histogram only, and I want to use these upper bounds, and so forth. Right? There's a lot of things you can configure. And this is not only for metrics, it's really for everything in the library, right? So these are the metrics properties. If you scroll down, there are for exemplars, for whatever. If you have the built-in HTTP server, you can specify which port it should use and all these things, right? So basically, you can override almost all of configuration at runtime, which is pretty helpful. And by the way, what we're looking at here is also something new. This is the new documentation that's hosted on the GitHub pages here. So the link to that is in the README file. And yeah, so it's kind of pretty extensive. So we have, quick start, walk through all the metric types. Callback metrics is something new that we introduced. If you want to define a metric, but call a callback to get the current value, hints how to use the API in high-performance applications, and so forth. We are going to extend this over time, and so try to not only provide a good metrics library, but also provide good documentation, which was kind of missing in the previous versions. Okay? Cool. So that was a little bit about histograms and about documentation and how to configure things and so forth. So let's move on to the other highlight feature that we have. With the new library version, you can now push metrics in OpenTelemetry format to an OpenTelemetry endpoint, right? Typically, the OpenTelemetry endpoint would be an OpenTelemetry collector. So if you are new to OpenTelemetry, this is OpenTelemetry collector is a project by the OpenTelemetry community. It's an open source project, and that's typically used to receive OpenTelemetry data and do something with that. For example, write it to a Prometheus server, which wouldn't really make sense in that case, but anyway. If you're interested in an example, of course, the examples directory has an end-to-end example of that as well, so basically setting up the whole thing. If you look at how that works in code in the example, it's basically just taking the defaults. So I initialize this OpenTelemetry exporter. The only thing I set in the example is I reduce the push interval to 5 seconds. So usually, the default is 60 seconds, which is good for production. So every 60 seconds you push metrics. For a demo, you don't want to wait 1 minute. So I just reduced it to 5 seconds. But obviously, this is just going with the defaults. So it will push to the default OpenTelemetry port on localhost. Obviously, you can configure a whole lot of things here in this builder pattern. And of course, you can override all the configuration at runtime as well. So if we get back to our documentation here, you see a couple of examples, which protocol to use, which endpoint to push to, custom HTTP headers, so in case you want to do HTTP authentication, and so forth, right? So lots of configuration options that are supported. So this is already cool, and also it kind of gives you the option to push metrics in OpenTelemetry format. However, if we aim at good integration with OpenTelemetry, this is not the whole story, right? Because OpenTelemetry is more than just a definition of a transport protocol, right? And one thing that's more in OpenTelemetry is that OpenTelemetry defines not only the protocol and the protobuf and how to push metrics. OpenTelemetry also defines standard metric names and label names. This is called semantic conventions in OpenTelemetry. And so, for example, OpenTelemetry says, if you monitor an HTTP service, then you must always have a histogram named HTTP server requests, right? And the idea is basically that if everyone uses these standard names, you can have standard dashboards based on these names and so forth. There is an issue with that, though, which is that those standard names in OpenTelemetry usually have dots, like http.server.requests, and dots are, currently at least, an illegal character in Prometheus metric names. And what we did now in the Java library is we allow dots in metric names. However, you will never see the dots, because if you expose the metrics in Prometheus format, they will be automatically replaced by underscores under the hood. So if you just use your library, even if you create a metric with dots, you will just see the underscores in Prometheus format. But if you push your metrics in OpenTelemetry format, then you will see the original names with the dots. And the reason why we do that is because if you instrument an application now, you might choose to use standard metric names and label names coming from the OpenTelemetry standard. Maybe you don't need to now because you don't use any OpenTelemetry specific tools, but this prepares you for the future if at some point, whatever you decide to use standard dashboards all based on OpenTelemetry names, then it's probably a good thing if you're using standard names in your instrumentation already, because then you don't need to change anything, right? And just allowing dots under the hood allows you to do that today, even if you don't use that, so that you're prepared for the future. So that's the naming part, and there's even more things that come with integration with OpenTelemetry. So the next thing is how it works together with tracing. So basically, OpenTelemetry, as you might know, is not only about metrics, it's actually mainly about tracing. So tracing is the strongest part of OpenTelemetry and the oldest and most mature, but it has metrics as well, logs, and they're working on other signals and so forth. And the way OpenTelemetry works, it's on purpose designed as a loosely coupled standard, with different components. And so it allows users to pick and choose the parts of OpenTelemetry that they like without forcing them to use the other parts. And so what that means in practice is you can, for example, decide to use the Prometheus Java client for instrumenting your application with metrics, but at the same time use the OpenTelemetry Java agent and attach it to get distributed traces. And for that scenario, the Prometheus Java client has a couple of magic things that then happen under the hood that make this scenario really a smooth experience. You don't really need to know these things, they just happen automatically, but it's kind of good to know what's happening under the hood. The first has to do with these attributes named service name and service instance ID. So this is something specific to OpenTelemetry. In OpenTelemetry, an instance of a service is identified by these two attributes, service name and service instance ID. That's similar to what you have in Prometheus with the job and instance labels, right? And what happens as soon as you attach an OpenTelemetry agent to your application for tracing, for example, then the Prometheus Java library will recognize that and will use the same service name and the same service instance ID that the OpenTelemetry agent uses. And then as an effect, if you push your metrics to an OpenTelemetry endpoint and you push your traces to an OpenTelemetry endpoint, the monitoring backend will see that these have the same service name and service instance ID, and then the monitoring backend will understand that the metrics and the traces are actually coming from the same instance. So that's a nice feature. Next up is Exemplars. So Exemplars is nothing really new, but it's probably a feature that not many people use. So it's kind of a way to annotate metrics with links to example traces. I can show you a quick example. So I started one of the demos before this talk. So in case you've never seen Exemplars, they look something like this. So this is just a latency graph showing 95th percentile of some latency. And the exemplars are those little green dots here, right? So each of these little green dots is actually a link to an example trace that happened here. And you see that there's a wide variety, so there's a couple of particularly fast ones that are well below all the other ones. There's a couple of particularly slow ones. And if you're interested, for example, so why is this one here so slow? Why is it well above the 95th percentile? You can click on Query with Tempo or whatever your favorite trace database is and start exploring what happened here. So that's basically a feature of the Prometheus data model and of the OpenTelemetry data model, that you can add these links to example traces to your metrics. And the Prometheus Java library does this automatically. So as soon as you update metrics while a trace context is going on, then it will add exemplars automatically. And this is actually nothing new. The previous versions did that as well. But there was an issue with the previous versions that is now fixed, which is that people who use tracing often tend to use some sampling to throw away most of their traces, because trace data is very repetitive. You get the same kind of traces over and over again, and it's pretty common to configure the OpenTelemetry collector and say, I want to throw away 90% of the traces and just keep 10%, because then I will still find enough examples of everything that's going on. That was an issue with exemplars, because that meant that 90% of the exemplars just linked to non-existing traces, right? You had a lot of 404 file not found. And this is now fixed, or at least there's a feature that helps you fixing it, because now with the new version, if the library uses a span as an exemplar, it adds a specific span attribute to that span, and then you can configure the sampling policy in your OpenTelemetry collector to keep all traces that are marked as exemplars, right? And that way, you will never have the dead links in your exemplars again. And also, there's a rate limit. You can configure, I want a new exemplars at most every 30 seconds or something, so that this will not overwhelm you with a huge number of traces in your backend. Cool. So that's the tight OpenTelemetry integration, so prepared for that world as well. To wrap this up, I want to mention a few things that are kind of unique to the library, or that is more like the focus of the Prometheus Java client here, which is that it's still, Prometheus first library, and mostly it's focused on being a high-performance library, and that shows in a couple of different places, and even shows on the API. And this is not really new. This has been around for a longer time, but it's kind of one of the things that show that it's actually 10 years of experience went into how this API is designed. And I have a pretty simple example here, but I like it because of its simplicity. So what you see here is how you would increment a counter, right? So you have a counter, say I have labels, values, whatever, some path and some status code, and I increment it. And the tiny trick here is that looking up the label values and incrementing the actual counter are two independent operations. So if you have a really high-performance web service that you try to squeeze the last bit of performance out of your service, what you can do, you can separate those two calls, right? You can look up the label values only once, and then store the resulting data pointer here somewhere. And then in the hot path of your web service, where you want to update the metrics as quickly as possible, you basically just use that directly to increment the counter. And this actually gives you more than 100% performance increase in the number of operations that you can do. And it's there's some more of these simple little things that just make it well suited for high performance applications. And the last thing is, you don't really need to know this because it just happens under the hood, but it's a cool feature. All of the metric types, including the new native histograms, support concurrent updates under the hood, right? So if you have a multi-threaded application, all the threads can update the data structure at the same time. And this is important because if you have a high, like I don't care about a single-threaded scenario, right? If you write an application and decide to use only one single processor core of your server, then you're probably not, writing a high-performance application anyway. But if you put in the effort to have a multi-threaded web service that's designed to utilize all available processor cores to the maximum to get maximum throughput, then the last thing that you want is you introduce your metrics library to measure latencies, and then the metrics library introduces synchronized blocks, and all of a sudden threads start waiting on each other, right? And this won't happen with the Prometheus Java client, so all of the implementations of the metric types support concurrent updates and scrapes. And there is actually a benchmark folder showing the results of that. So you see this benchmarks folder here. A couple of benchmarks in there already. Most of them focus on this updating metrics in multi-threaded scenarios. And the benchmarks looks actually pretty good. So that's nice. Cool. So that concludes my talk. So that were a couple of the highlight features here. Maybe quick outlook for the future. So when we cut the 1.0 release, we didn't port everything from the previous releases over yet. And there are actually a few things that have quite a lot of users that we also didn't port over yet, like the push gateway or the servlet filter and so forth. And of course, the next couple of weeks, we will continue porting things over from the 0.16 version to the 1.0 version so that you kind of have the complete feature set again. And of course, there's the other Java-related project in the Prometheus community, which is the JMX exporter. And we will port that to the 1.0 version as well, which will have the interesting side effect that you can push OpenTelemetry metrics from the JMX exporter if you like to do that. Cool. So that was my walkthrough, the new Prometheus Java client. Try it out, create issues, contribute if you can. And yeah, thanks for listening. Happy to take questions.
So if I'm starting my new Java application now, what guidance would you give me to choose whether to instrument it for like with the OTel client library or Java client?
Sorry,
So now we're in a position now with the Prometheus client Java supporting OTel, the OTel client supporting Prometheus. I kind of have a choice, right?
Okay.
How would you choose which one to use, or what guidance would you give me?
That is a good question. So the question is, like, there are multiple libraries. There is an OpenTelemetry library that supports Prometheus. There's a Prometheus library that supports OpenTelemetry. Which one to choose? And actually, that's like a very common thing in the Java ecosystem. There's even more. There's Micrometer from the Spring project. There's lots of different libraries. And the question is, how would you choose? So there are differences. I mean, first of all, even though we have OpenTelemetry support, that we built this OpenTelemetry support mainly with this use case in mind. If you instrument your application now, maybe you're using Prometheus scrapes today, but maybe there is a chance that in the future your company says, we're going to standardize on OpenTelemetry and push everything in OpenTelemetry format. And with this OpenTelemetry support, we want to make sure that if that happens, you don't need to throw your instrumentation away. You can just keep using it, then you just switch on the OpenTelemetry exporter and you are done. But that doesn't mean that we are going to become like an OpenTelemetry library, right? It's still a Prometheus library. It's still a direct implementation of the Prometheus data types, right? And it still does not implement some things that exist in OpenTelemetry but do not exist in Prometheus and so forth. So it's really focused around the Prometheus data model, and it's focused around being like a very high-performant and simple library. The other, like for example, OpenTelemetry is a bit more generic, is a bit more designed to work with the Java agent, is of course, a bit more complete in terms of what the kind of concepts coming from OpenTelemetry it supports. But yeah, probably a bit, you need more lines of code to use it, let's say, put it like that, right? Yeah.
Any other question? In the meantime, I have a question, if I can, again, sorry. So thanks for your talk. And my question is, do you need contributions? What's planned for the future? If anyone wants to help you with the client Java, contribute, like what's exciting you have for them?
That is a great question. Yeah, contributions are definitely welcome. I mean, first, of course, we need to port over the existing simple client modules to the new 1.0 version. So if you are a user of one of these and you want to speed this up, maybe just port yours and make a PR. I mean, that would help, right? Yeah. Then, I mean, all kinds of things, right? I mean, we have these examples that we want to extend. You can also, if you're not a coder, contribute to the documentation. So, of course, the thing that we saw here, our documentation page, is also just in the docs directory on GitHub. So it's just Markdown files. You can easily, write something, or implement new features, like, for example, something for instrumenting Java flight recorder might be nice, stuff like that. So there are a lot of ideas, instrumentation modules that don't exist yet.
Thank you.
You know who to reach out to. So.
Yeah.
Okay. Then thank you, Fabian, again.